So as we saw in some earlier posts, using CFImport is a really nice way to create usable ColdFusion custom tags. However, in Lucee CFML, it turns out that when you use CFImport, invoking those CFImport based custom tags actually has a file IO check on every single invocation, which I consider a bug, but that's neither here nor there. In a regular application, that might not be a problem, but in a containerized application, such as inside of Docker, where you're dealing with multiple layered file systems, that file IO actually has a significant performance hit. So what I've been exploring is a way to bring performance to CFImport by moving away from a single pass paradigm to a two-pass paradigm, in which the first pass actually compiles the CFML code, essentially removing the CFImport usage, and then the second pass executes the generated code. So to see what I mean, let's take a look here at what's going on. I have this core content ColdFusion custom tag, and that's going to be the tag that generates the CFML code to disk and then executes that file on subsequent pass. And the first pass is going to execute the CFML code. And you'll see here that I have a couple of tags that look like runtime : but if we jump up here, you can see that there's no import with the custom tag prefix runtime, and that's because this is not actually the invocation of a ColdFusion custom tag. It's just special HTML code essentially that gets parsed differently at compile time. And what we actually do is replace the runtime : with CF. So runtime set becomes CF set, runtime output becomes CF output, and runtime loop becomes CF loop. So you can start to see that there is always going to be this confusing overhead of having to mix compile time and runtime syntax within the same template. And you can see here we have some more of that complexity where I have to replace the hashtag interpolation syntax with the open curly brace, close curly brace interpolation syntax. And that's because this interpolation is happening at runtime, not at compile time. So in this demo here, I'm at runtime creating this request of, this array of values, and then at runtime I'm looping over that set of values, and I'm invoking this ColdFusion custom tag, and I'm passing in the value. Now the ColdFusion custom tag here is actually a compile time directive, and the compile time directive outputs ColdFusion code, which then has to execute during the runtime step. And again, you can start to see that it's just confusing having compile time and runtime concepts mixed in the same template, but I think that's just where we're at now. Now, because I have to evaluate this request.value at runtime, it means that I can't pass in an interpolated value like this. Instead, what I need to do is pass in the string request.value, which is what the runtime variable name will be. And if we look at the item, what we can see here is that that attributes.item is being, again, passed in as a string because it's not a compile time value, it's a runtime value. And then inside of this ColdFusion custom tag, you can see that I'm doing a runtime interpolation of that compile time value, which is the variable name, not the variable itself. And then ultimately, if we just jump over into the browser here, we can see that I looped over A and B and C, and I'm not getting B. And again, because if we look here, we can see that at runtime, if the passed in value is not B, then we output. So essentially we're skipping over B in this A, B, C value. Now, the cool thing about this approach is that the content tag here is actually writing the generated CFML code to disk and then executing it on subsequent requests. So if we jump over into the content tag and we go up to the top, what we can see here is that at the start mode, we create the file name here that we're going to use for our cache template. And then we're going to attempt to include that cache template and then exit out. So if that cache template exists, we only ever execute the start mode of our CF content, which means that we never actually execute this code on subsequent requests. We're just pulling the generated CFML off of disk. And the nice thing about this is we can actually look to see what this template is, to see what the generated code is. So if I open up the cache template here, you can see here's my runtime request values array, and then I'm looping over this now interpolated array with my local variables, and here you can see that the CFIf value not equals b, which was part of my ColdFusion custom tag earlier, is actually no longer inside a ColdFusion custom tag, because the ColdFusion custom tag was a compile time concept, and now in the runtime mode we don't even have it. So it's essentially been compiled away, which means that we don't have that overhead of the CFImport tags anymore. And what else can we look at? And so let's look back at the CFML tag, or the content tag. So here we're in the start mode. Again, the first attempt is to try to read it off of disk. If that throws a missing include error, then we allow the body of the content to execute. That'll generate the CFML output, so it's generating the ColdFusion markup code. And then in the end mode, we take that generated CFML code, we convert it over to actual CFML. So we're taking those runtime prefixes, we're replacing them with CF. We're taking our curly brace interpolations, we're replacing it with actual CFML interpolations, and we're just stripping out blank lines, and then I'm just writing that to disk. And you'll see that we're single threading the file IO here on write, but we're allowing for concurrent reads in the start. And that way we make sure that only one request ever writes that CFML template to disk, and we're performing essentially a double check lock. You can think of this missing include as the first check, then we enter the exclusive lock, then we're performing the second check of the double check lock pattern, and therefore only one request is ever actually writing to disk. So we shouldn't get any weird kind of overwriting of existing code or partial template writes, that sort of stuff. And then you can see here I'm just including the template that was just written, and we're overriding the output of the custom tag. So that's what we get here. And if let's go in here and now let's delete this file. Okay, so now we've deleted the cache template, and what we can see is when we run this again, the first request here, which has to do the CFML compilation and the file IO to disk, is 98 milliseconds, which is relatively slow. But now if we refresh, 24 milliseconds, 16 milliseconds, you can see now it's going much faster because it's not actually doing any of the compilation. It's just reading in that CFML template and executing it like it would any other ColdFusion template. So it's going back to it's unfortunate that we have this now mixture of runtime and compilation time values, and the compilation time values then also have to worry about runtime references versus compile time references. That's unfortunate, but I think that that's just sort of where we're at. I had hoped, again, with the CFImport that I could just have a purely CFML approach and it would just work and we didn't have to have a compile step, but because of the overhead of CFImport in Lucee CFML, because I'm running inside a containerized context where the file IO has significant performance overhead, there's just no way around it. I think I do need to have a compile step versus a runtime step. But ultimately, my North Star, my immutable truth, is that I just want it to be a CFML solution, a ColdFusion solution. I don't want to have to install Node.js or install Ruby to compile my CFML templates. That's crazy pants. I'm tired of living in that sort of world. So what I want is my ColdFusion to generate my ColdFusion, and that makes it easier to understand and maintain over time. And anyway, this is a standalone demo. We'll see what happens now if I try to take this approach and apply it to my ColdFusion custom tag DSL for HTML emails, and we'll see, one step at a time.